temperature, wind speed, electrical faults, having the system not work with nothing wrong. All of those things are going to impact the electrical characteristics of the system. Temperature will result in performance loss, but that doesn't mean both voltage and amperage are decreased with temperature. As temperature increases, voltage drops. As temperature increases, amperage increases. But overall power, which is a volt times an amp, decreases. And what that means is voltage is more impacted by temperature than amperage. So on hot days, voltage drops a lot, amperage increases a little. On cold days, voltage increases a lot, amperage decreases a little bit. I've had a couple of installs where the overcurrent protection device, the fuse, the breaker, was undersized too much, and that can happen if the on smaller breaker sizes where you're rounding up to the nearest breaker. The installer might have really needed a 30 amp breaker instead of a 20 amp breaker, but they didn't get it. And to move forward with the job, they just stuck the 20 amp breaker in there because the continuous operating of the system said it should be at 18 amps. So they're like, all right, well, if it goes more than that, it's just going to trip the breaker and turn the system off. We got the breaker in our car. Let's keep moving with the system. Well, when will that undersized breaker trip? Will it be on the hottest day of the year, or will it be on the coldest day of the year? You would say, okay, well, it could trip on the coldest day of the year because presumably under full sun, on the coldest day of the year, if the solar panel is facing the sun directly, it'll produce the most amount of power and the breaker will trip. Well, not actually, because that breaker is tripping off the amperage. And so if the voltage is way high and the breaker is rated for that voltage, your amperage, might still be, right where it's at on the spec sheet, if not a little bit lower. The system on a hot, sunny summer day, the amperage may have climbed even though the voltage is down, to the point where that 18, 19 operating amps ekes up to 20 and flips the 20 amp breaker. So when breakers are tripping, there are reasons for it. Now, NABCEP also says, well, wind speed impacts solar performance. Very little. Wind speed, ventilation underneath the solar array, it does have an impact on solar performance. If you use a frameless solar module and you run the rails straight up the roof, so underneath the solar array, there's just a flat sheet of glass and nothing else, as opposed to using framed solar modules where the air underneath the array gets caught and it heats up. So you're trapping hot air underneath the array, whereas a frameless module will let the hot air roll out the top and have some airflow underneath. Well, which array is going to produce more power? The one with the airflow underneath it. So you go and you model PV watts and you do a fixed in place array on the roof versus a fixed in place array on the ground. PV watts is going to model slightly more wind speed and slightly more ventilation on the ground mount array rather than the roof mount array, and show you like a 0.5% or less increase in performance. So yes, having airflow and movement underneath the array does improve solar performance, not by any kind of significant amount that I think is worth talking about, but it could be on a quiz question. That says in the eyes of a quiz is that solar on the ground with more airflow underneath might perform better than solar on a roof with no airflow underneath. But in the field, it's a lot more murky. Solar on the ground might get more dust on the panels. and so it might produce less than solar on the roof. But if that dust also gets on the rooftop, solar on the ground with more frequent cleaning will produce a lot more than a dusty solar array on the roof that doesn't get frequently cleaned in a particularly heavy dusty area. So the actual field parameters should design that. But when you're taking an exam, you have to think about, well, the exam questions are technical, and so if it's asking me about wind speed, it's asking me not not how wind speed impacts dust in West Texas country road, but in an otherwise neutral environment where the only condition that's different is the wind speed. How does that impact solar performance? A ground fault is short circuiting a circuit and a properly sized system. So, will the conductors burn up in this circumstance? Why or why not? Well, that's where we go and look at the spec sheet and you say, okay, well, the system was designed at a particular amperage. Was it designed at the operating amperage or the short circuit amperage? Well, the proper way to size the circuit is to start with the short circuit amperage and then upsize by 25%. So if a short circuit is occurring through the wires, then the wires and the terminals should be able to take that current and shuttle it off to ground. Now, if that effective ground path is impeded, you could get some burning up. But if the circuit is just the 8 amperage that's coming out of one circuit and it's faulting into the appropriately sized ground fault path, then it should not result in physical damage to the array. And so if you have a breaker that's tripping and you go and give the array a visual inspection and you say, okay, well, everything looks good, it still might not be good. The breaker's not tripping for no reason. You have to identify the cause for it. It could be a ground fault that has not resulted in a substantial fault. It could be an MC4 connection that when it rains, the water is getting into the connector and shorting it to the ground, and then it stops raining and dries up and the fault clears. Just because you don't see the home burn down doesn't mean that there's not a problem going on with the system. But the conductor should be sized to take, a normal ground fault current. And here's another question. A charge controller has a safe VOC mode, which prevents the system from turning on due to extreme temperature. So is this safe VOC mode protecting the system on hot weather or on cold weather? What is VOC? Well, VOC is the open circuit voltage. Just like circuits are designed not for the operating amperage and operating current of the system, but its maximum amperage, which is what it would be doing if it's all amperage and no voltage. It's going towards a short circuit amperage. If there's no load, if no power is being taken out of the array, it's all voltage and no amperage, and so that'll be its maximum system voltage. And so systems are designed around the maximums, around the short circuit current, around the open circuit voltage. And so this is saying, okay, a system is running at its maximum voltage. And what it's saying is maybe this maximum voltage is beyond the voltage rating of the component. So this would be a system that detects when the voltage is unusually high and turns the system off to avoid running that high voltage through the components. And it might be that when the system turns on, it drags down the voltage to a safe operating parameter, but in that transition period from unacceptably high voltage to lower voltage, you could cause damage in the electronics. Voltage is more like the skin of a water balloon, whereas amperage is more like the amount of water that the cable can shuttle within it. You're going to get more and more and more water, and all of a sudden you go past the point of no return and there's an explosion. Voltage is more likely to pop things, toast things instantly just because the current runs through it. Whereas an overcurrent situation, if it's causing a problem, it's usually going to start smoldering the terminal. You're forcing for whatever reason, there's more current faulting through something that it shouldn't be there. It's going to heat up and start smoking. Whereas voltage, it's really just going to pop whatever little computer chips are managing things. And so when you get into high voltage situations, it's going to be on cold days. And so what this safe VOC mode is doing is on very cold days, it's going to be monitoring the system voltage. And if the system voltage, because of the cold weather, is too high to turn the system on, it's going to wait. And presumably the sun's going to come up, and that sun is going to heat up the panels, and when the panels heat up, it's going to drag down the voltage, and then the system will turn on. So a safe VOC mode might have the system sleep in on a cold day. That's like in the midnight charge controller series. And what it does is, in those extreme environments like Alaska, where it gets super cold at night, and it's still super cold before the sun comes up, it allows you to squeeze another module onto the circuit and say, you know what, right when the sun's coming up is right when the panels are fully energized. We're going to not turn the system on. We're going to let the modules heat up for a little bit, and then we're going to turn on a larger system, and that larger system is going to produce more energy than the smaller system. So there are kind of advanced design features in some of your higher end components that let you squeeze a little bit more juice onto the same component piece.